basically the customer saved literally millions in unnecessary upgrades by us having done this audit and identifying the hotspot that needed to be addressed. Obviously, the return on investment for our client was extremely attractive. Hi, I'm Eric from Alpha Power Solutions, and today we'll be talking about the importance of regular testing and monitoring for harmonics. To start off, let's just define harmonics. So basically, they're a form of electrical pollution generated by variable speed drives, UPSs, soft starters, drives, DC drives, basically non-linear nodes. And it's just a byproduct of these devices. And as a result, these harmonics generated by these devices are trying to go back to the power source. So basically, they travel upstream and they radiate within a distribution network. So elevated harmonics can result in premature failure of electrical and electronic equipment, but there's many other factors or side effects of elevated harmonics. Don't make a mistake in the sense that certain levels of harmonics are acceptable. Perfection is not required. In fact, there are standards available up to the 40th harmonic where it's clearly defined what is found to be acceptable and what is not acceptable. Now that we have this out of the way, let's define what a harmonics audit is. Well, basically, it's an exercise where the harmonics are measured and recorded in order to identify the main contributors to the harmonics present in a factory. And basically, once you have that information, it's then possible to identify the corrective action that's required and do it as cost effectively as possible. Again, I want to reiterate, up to certain limits, harmonics are totally acceptable. It doesn't have to be, completely eliminated. So how do we do an audit? We basically use specialized equipment and we start at the main distribution board, find all the feeders, take measurements on all the feeders, identify the most problematic ones, then go further down from those feeders, see what equipment is connected to them, measure the harmonics on each of these main machines connected to that feeder, and ultimately you find the culprits. And then, depending on the number of culprits, and the severity of the problem, you might have a fairly cheap solution where you just put a line reactor in series with a variable speed drive, for argument's sake, or you might have to go for more expensive and more sophisticated solutions where you need to install active harmonic filters. Elevated harmonic levels can result in a number of negative aspects. For example, it can result in the premature failure of electrical and electronic equipment. It can result to electrical cables overheating. It can result in the nuisance stripping of circuit breakers or fuses blowing for no apparent reason. You basically reset the circuit breaker or replace the fuses and everything starts to work normally. You can result in the overloading of the neutral circuits. It can result in the derating of electrical equipment where you cannot use the full capability of the equipment. I'm talking specifically about motors, transformers, UPSs. Elevated harmonics can also result in the failure of capacitors. They also result in increased losses and higher electricity bills. Can result in incorrect readings of power and energy meters by certain brands or certain types of meters. Can result in a poor power factor, especially when there are data cables running close by electrical cables that contain a lot of harmonic components. It can result in resonance issues between the supply transformer and a power factor correction system. And in motors, inside electrical motors, it can result in overheating, vibrations, and reduced efficiency. So there's a lot of side effects from elevated harmonics. So it's not a matter of doing frequent audits. That's not required. Typically, audits are done when a new plant is commissioned to make sure that the levels are all acceptable so there won't be any disturbances or premature failures of equipment. It should also be done after a major expansion project where lots of equipment was added or old equipment removed and new equipment installed. So yeah, basically any significant electrical upgrades. Also the replacement of when certain drives or in rectifiers or any of that type of equipment that is drawing a lot of power is replaced with something new and more efficient. That new equipment might result in some additional problems such as super harmonics or supra-harmonics, but that's a topic for another discussion. It's also, when you require an audit, when you have unexplained electrical problems. Like I mentioned before, if things suddenly misbehave, but then things going back to normal once something gets reset, typically, it would be good to do an audit. And an audit isn't really that expensive. Yes, you need obviously the right test equipment, but in terms of the actual investigation, it goes pretty quick. Typical plant, you wouldn't spend more than a technician would do a full audit within a day, not more. It's not a lengthy process. All we need is basically that the factory is operational at pretty much close to full production. These are the ideal conditions for us to carry out these audits. So a couple of weeks ago, we were contacted by a customer in Cape Town who experienced supply transformer overheating after a major upgrade. Basically, old equipment was taken out, brand new equipment was brought in, and especially quite a number of large variable speed drives. So when we carried out the audit, we saw that, well, in terms of the actual kilowatts drawn by the upgraded plant had dropped, and the power factor correction, the system was working properly. So in theory, the supply transformer was actually less loaded. There was less power being drawn by the factory to operate these machines. So somebody recommended to our customer that they should upgrade their supply transformer, but that made no sense to us because the factory was drawing less power. So why, and spend all this money on a major upgrade of not only the supply transformer, but the main distribution board and everything else? So when we carried our audit, we found the main sources, and it was actually a fairly cheap solution. There were 4 variable speed drives that needed a line reactor. We supplied and installed these reactors, and everything was sorted. So the harmonic levels dropped within acceptable levels. The transformer wasn't overheating anymore. So basically, the customer saved literally millions in unnecessary upgrades by us having done this audit and identifying the hotspot that needed to be addressed. And obviously, the return on investment for our client was extremely attractive. Basically, an audit gets carried out as much as possible when the factory is in full operation. We really need all the equipment to work so we can find the culprits that generate the biggest amount of harmonics. So we come to site with the right test equipment. Our technicians have the right PPE because we basically have to measure or do live measurements. Come fully prepared with the right face shields and gloves and the right fire-resistant overalls. Anyway, anything that you need to be able to do this type of work safely. An audit starts typically at the main distribution boards and you work your way downwards from there. Ideally, we request a single line diagram from our customers so we can really, have a good picture of what's installed or what's connected to what within the factory. That simplifies the identification of the problem areas. So the customer won't really know that we're busy with the audit. We will not affect the operations of a factory in any way. On the contrary, we need it to be running, like I said before. Well, my recommendation is for any business who experiences any of the symptoms that I've explained previously, just to contact us and we'll arrange for an audit. Like I said, again, the audit is really required so that you find the low-hanging fruit. The low-hanging fruit is any device that generates the biggest amount of harmonics. So typically, we want to try to apply the 80-20 rule. In a typical factory, you will see that in most instances, there's only going to be 3 or 4 problematic areas within the factory. And if you take care of these, the levels of the harmonics presence will really drop within acceptable limits, and the problems will go away. So what we try to do, the audit is so crucial to actually find that sweet spot where the customer invests the least possible amount of money for the biggest return in terms of reduction in harmonic level. And so the audit is extremely is crucial in identifying the best possible return on investment. So for businesses not to address harmonics present in the system can have major repercussions, because it will result in premature failure of equipment. It can result in additional waste being produced. The operating costs will go up. That means that the profitability goes down. That means that the viability of the business is potentially under threat. So ignoring these symptoms is really not the way to go. You must realize that at least an audit is not really that expensive. It's just, some travel time and some investigation on site and then a report. So it won't break the bank. The solutions might be expensive, but not necessarily. It all depends on what the problem really is and what's required to fix the problem. But usually it makes no sense to ignore those symptoms and just keep on replacing failed components and just carry on wallowing in that same electrical pollution. Well, thanks for watching. If you found this helpful, please like and subscribe. There's a blog with more info linked in the description below.